thumbs up. I think I need you as just like the intro to the videos where it's like, hi, welcome to math today. All right, so those of you playing along at home, it's the 7th. So times 5 would work if we were going from 3 to 15, but it doesn't work otherwise. -2 to -5, I could like minus 3. I don't know.
Yeah, but you still have a plus.
Simon, what are you thinking?
Alright, so you multiply by 4, which would get the 1.5 up to 6, and the -2 up to -8. But when you add 3, that then brings that the 1.5 up to 9, and the -2 up to -5.
So you're saying we multiply by 4 and then add 3?
And that's why when you multiply 3 times 4, which would be 12, and you add 3, it seems like you're multiplying by 5.
Ah, let's try this. There we go. Very good work, Simon. One more, and then we'll dive into actual class.
Times 1 plus 5.
This would be -5, dude. Or no, this is what? No. It could be times -1, maybe. Right? Because this turns from a positive to a negative.
That's it.
Test it. If we do times -1, that turns into 6.
Times -1 plus 5.
Times -1. Hold on. Times -1 would turn this into 2. So, hey, I'm going to ask, I know I haven't clarified this maybe like definitively, and it's a new week. When we do these, because we're going to have these almost daily for a little while, please don't shout it out. I liked that very quickly people, whether they were serious or joking or whatever, were like, oh yeah, just -5, whatever. Like, this, they're 5 apart. No. If I flip this to the opposite, now they're 5 apart. So, as Simon is desperately trying to get us to hear him say from back there, it's not add 5, it's add -5. But wait, that's wrong! I know! What?
Yeah, because a negative times a negative equals 1. Double negative.
So wait, this, hold up, if we test this, hold on. If we test this, -6 times -1 becomes +6. Right, take away, yeah, that works. -2 times -1 becomes +2. Take away 5, -3, okay.
Wait, so I
Maybe
almost got it.
that was just formatting.
Okay, that's stupid.
So, that was, as much as I dislike Bear just shouting things out whenever he feels like it, that was one of those dumb occurrences where formatting is what got us. Right? If we have addition here, would definitely tell you, put the negative in parentheses. But with how they coded this, it was looking for a specific answer of -5 to be typed in. So that's why also we're doing stuff on worksheets this year. Not like a few years ago we did online modules and things like that that would give you instant feedback. And they were not always very forgiving. All right, so. You what? Not right now. I'm not going to take those anymore until the end of class because and really if that's a distraction, we're going to put the lid on that real quick if it's distracting people. So when we look at graphs, we're able to determine certain things. We've talked about x-intercepts and y-intercepts and things like that. But then when we just have points on the graph, we need to be able to locate where that point actually is. So with A, anyone kind of notice like sort of like an issue there?
Yeah.
Alina?
There's only 1 point, so you can't know it's
Well, there's only 1 point. I agree with you that there's only 1 point. I got another issue though, aside from the fact that there's only 1 point. Standard? Bless you.
We don't know,
Bless you. We don't know what the intervals are on this line. Right? Now, for us, we're always expecting that you are going to put intervals on here, that you're going to include your scale. But if it's not included, and I hate doing this, but what's the assumption? That it's 1, right? We assume if there's no scale given, that's because it's a 1-to-1. So if each of these is worth 1, what's the location of point A right here? If the tick marks are worth 1, Mr. Dale? 2, 1, right? It's 2 over, 1 up. So then they ask us questions like this. This is 52. Now we're going to want to write something down. So for B, I'm not real worried about you writing anything down. For B, it asks us, where will the line be when x is 5? I want you to talk with your partner. How can we solve this? Where will the line be? So what it's really asking is, what will the y value, right? What will the y value be when x is 5? I'm not your partner, but yeah. No, I said talk with your partners. Well, what? Yeah, it's a straight line, right? It's going to continue straight.
Well, yeah, but I mean, like, for x, when y reaches 0, it's like barely below 3. Should we just count that as 3? Or?
Yeah, it's really close, right? That's kind of annoying. There's a question in my head that wonders if it's a Zoom format thing, but it does not look like it's a formatting issue. So Simon's frustrated at what I'm frustrated at. This doesn't quite line up. Now, hey, Katie Ann, you got something that we all got to talk about, or what's going on back there?
Looks like a fence.
So I'm just confused why we're talking.
Oh, it does.
If I cheat a tiny bit and give some grid lines, we can kind of see things a bit more easily. Kind of.
They're not even boxes, they're squares.
Well, yeah, they're rectangular because they're up here.
Those
But
make me mad.
Our rockets on order.
so we have a y-intercept
Good guess.
about 2.5, right? Y-intercept is 2.5. So that point, please write this down, is 0, 2.5. Sure, yeah, I mean, that is our y-intercept. Now what you're saying is not true. You can find the slope. You're just struggling. So don't say I can't.
Well, no, it's because there aren't really any clear, like,
Ooh. Yeah, keep going.
there aren't really any clear dots that you can find on the line where they are exactly like lines, like dots that are given, like, in the line that aren't very clear.
Yeah, it doesn't cross like the intersections.
Yeah.
Right, so what Alina is getting us to up here is there are no intersection cross points. Like this would be a nice cross point. This would be a nice cross point. This would be a nice cross point, and this doesn't.
2.5 is also.
Yeah, 2.5 is okay. Right? Now, if I try to approximate this point the best possible,
2.8.
yeah, that's not as nice as maybe 2 3/4. Maybe, I mean, we could do 2.8, but if we do 2.75, let's go ahead and write that down. That's our x-intercept. Right? That's where we cross the x-axis.
Whoa.
When we talk about slope, did we talk about what division gets us slope?
Yeah, we talked about y1 minus y2 divided by
What?
x1 minus x2.
Slope,
Oh, yeah.
technically we say it the other way around, y2 minus y1, x2 minus x1.
Oh, yeah.
You just put the ones in front of the twos, but technically it doesn't matter, actually.
It doesn't.
Yeah, so when you say it, it's 2 then 1,
Yeah,
but it doesn't matter. I don't care how you do it. M is how we notate our slope. Don't ask me why. At some point, somebody decided M is the abbreviation for slope. It is your change in Y over the change in X. You should write this down because we're going to do this a ton this year. Our change in Y to go from 2.5 to 0 was a negative 2.5. We went down. Our change in X was up, right? Because X went from 0 to 2.75. Change delta. So that, sorry, I'll make this reminder as many times as we need, but we talked about last week, that's a Greek symbol. That's actually a letter, technically. It's a Greek letter called delta, which we use in math and science and any branches of math and science to mean change, the amount of change.
I was absent on Tuesday, so that's probably why I don't know.
Yeah, that could be it. That might have been we covered. Yeah.
Sorry, I was looking at it the wrong way.
So, especially, I could make this negative 250 over 275. Right, if I multiply the top and the bottom both by 100. How many 25s are there in 250?
Quite a bit.
That's our slope, right? Now, if we're using the points we wrote down, so guys, you should be doing this with me. I should see pencils moving and brains turned on. Yeah? Yeah, confused where? So that was the change in Y. Y went from 2.5 to 0. What was the change to get there? We went down 2.5. The change in X went from 0 up to 2.75. So we're using this point and this point, even though it's a little funky. Now, if this was 2.5, this would be really easy. Yeah, then it'd be negative 1. But we're going to go ahead and solve it the difficult way, just for fun. So this is our slope. Are we okay? I will take questions, but are we okay on how we got our slope? Liam.
I'm confused. Like, so I get what you did. You just simplified that.
Mm-hmm.
But I'm confused how that number represents the slope. That's what I'm confused.
So every time we go down 10 squares, we would go right 11 squares. Because remember, the x's are left, right, the y's are up, down.
Oh, okay.
So this is a weird slope. We normally have nicer slopes than this. But then we could actually set up our y equals mx plus b. And guys, this is where I really want you with me, because this is where you will see how this can work easily and how this cannot work so easily. So please write down y equals negative 10/11 x plus, you can't run the whole class, but I'll let you do one more. Do you want to save it or what?
So, the y-intercept is 2.5.
Remember, this is slope-intercept form. So we need to plug in the intercept that we said is 2.5. To get our y value, we just do math. This is the equation of our line. It is the slope-intercept form. So first off, you're going to say what? Put your book under your desk. This is our slope. It's the thing in front of the x. I know, I'm just saying, just get it out of there. No need. This is the y-intercept, and that is a weird color. So now, we know what the x is. What x are we trying to work with here? The problem asked us when x is 5. So we plug in x is 5. So this becomes y negative 10/11 times 5 plus 2.5. Patrick, did you already do it?
Why is it plus 2.5?
Because that is our y-intercept. Remember, it's slope-intercept form, and the first thing we recognized was our y-intercept, where we cross the y-axis. 2.5. So you need to remind yourself, if you need to remind yourself, y equals mx plus b is what we call the slope-intercept form because m is the slope, b is the intercept. So you need to remind yourself that. Please write that down. That's slope-intercept form. Alex.
Is this like what we did at Atrium where you made the line where you had to get the ball into a certain point and
Or the plane onto the
and then you had to play and then you had to type in a certain equation to show the slope.
So guess what we're going to do at some point again in the near future? That activity when we know a whole lot more about it. But you'll be so good at it now. Yes. The other way that we talk about m, because that's what delta y and delta x, that's what those things are. This is the rise. This is the run. But why I don't only use those words, rise makes people feel like it always goes up. It doesn't here. It's going down here. Right? So although we can say rise over run, it's really delta y over delta x. Change in y, change in x.
You could just
Liam?
So if the negative
Y is the
2.5 is y,
It's the y-intercept. So we still have to do this math.
X is
so what's the
Y
11?
is the elevator.
The negative 10 over 11.
That's the slope. That's how our line is changing. So y equals this, and when we do the math, it's going to be around 7.5. It's going to be really awkward. Anyone do this? Yeah, 50 divided by 11.
I mean, I was just able to think about it in my brain and able to get that 1 is over 1.1, but I don't think that's the answer.
Well, this comes out to be negative 4.54545 because, 11ths repeat. So then if we add 2.5, y is negative 2.045, and that 45 is going to repeat. Now, that's a difficult way to do that. Well, negative this, then plus this was negative 4 point something. And why would the y value be negative? Because we're out here. Right? This line is going to continue going out to here. And that point where x is 5 is out here.
I like personal.
Alina?
Can
Yeah.
you go up to the slope?
I just want to take these
If
courses.
the slope is like, if the top is like a negative, then it goes.
No, well, it depends. If they're both the same sign, it's a positive slope.
Well, yeah, but I'm saying if the top is a negative, then that means that the y goes down. And then
Yes.
if the x is like a negative, then
Means we went left. So that would be you would have to be thinking about traveling left. We almost always think about traveling right. And that's why we almost always have a positive x. So let's do a couple more of these to make better sense of this. What is t when k is 1? Well, this, we don't yet understand, that this is a parabola. And we talked about it, but we don't know how to derive the formula, right? I don't even right offhand know how to get you the exact formula right now. So sometimes we just plot and or trace and follow and so when x is 1, well, okay, so we find where it hits, go over.
That's one of the lines I've ever seen.
Is this even solvable?
Well, the problem is we don't have any tick marks.
It looks like a round.
So it's gonna be, well, hold up. What is this? That's 2.
It's gonna be around 1.
It's gonna be around negative 1.
Yeah, that's what I meant.
Right? It'll be close to negative. It probably is negative 1. Right? It probably is negative 1.
Show us how to write down some parabola.
Yeah, in a moment. But especially because people with yellow sheets don't understand the first question, and that was my point. We're not jumping straight into it. So, we are going to make a graph on our graph paper. But we're not going to make it 1-to-1, right? We're going to give it a different scale. So please make a big XY axis, like pretty darn big. I mean, if you have at least half your sheet, that's big enough. Because we're going to do multiple graphs on this. I just said. Half your sheet would be big. Like, we're going to graph 3 different graphs. Just make an X and a Y axis. Sure, you could just flip to the back. Hey guys, this does not take talking, and it gets mildly frustrating that I have to deal with that in this class. Just trying to find a pen that works and isn't going to get stuff all over me. But that's a struggle right now.
Pens live there.
Oh, they're broken.
What about the pens? Pens like that. How do you break?
It's really easy to check.
How do you break a pen? Oh,
Exactly.
I know.
Now you want this graph in the x's to go from -5 to +5, and in the y's to go from -5 to +5. You are choosing the biggest, most spread out scale that you can. So if this is my graph paper and I want to go to +5 out here, if this is centered, I should be able to think this through kind of both ways at the same time. Count your boxes, right? 1, 2. 15, I could make every 3 boxes 5. I'm going to double check over here that I could do that here as well. We won't quite make it out. This is 14, but I'm going to go ahead and do it. This is as big of a scale as I can pick. 3 boxes equals 1. Depending on the size of your boxes, yours will be different.
I have the same paper as you, so.
Yeah, if you're using the 5-star paper, it's probably about the same size. And then the same scale has to be on the negative side, right? We can use a different scale for the Y if we want, but the same scale has to be on the positive and negative. Sorry, I have the angry monkey today because Mrs. Golding's phone is charging. When that ringtone goes off, it reminds me of just an angry monkey like on a keyboard. Now, I could make a bigger scale. I could probably go 4 boxes is 1, but I like things when they are the same, X to Y. So I'm just going to make my Y scale the same every 3 boxes.
Is it supposed to be more than the x-axis?
It may end up being more, so if I have the space, I mean, sure, it does become more. Please make sure you always label your x-axes with an X and your Y with a Y. Now your next objective, and I'm not going to show my graph while I do this because I want you to take a minute to try it on your own, is to graph these 3 lines. Now, I will tell you, if you don't yet understand the slope-intercept form, that's totally fine. The way that always works, and what I've given you an opportunity on your homework to kind of use this strategy as you go, if you've looked at the yellow sheet for today yet, is you can make a table, right? We can always make a table and just fill it in. So if I'm trying to determine what the Y values are for this, here's my strategy, like my legitimate strategy that I used to use when I was trying to learn this stuff. I want to make an XY table for this graph. Thing is, I want some negative, some positive, and we always want the 0. 3 points is minimum, 5 points is safe.
That's
3 points is the minimum to see graph behavior. 5 points is safe. So I choose 2 negatives, a 0, and 2 positives that are the same numbers as the negatives. So you could do like -4, -2, 0, 2, and 4. Since our graph goes -5 to +5, this will nicely spread some points out across the graph. But now we plug this value in and see what the y comes out to be. The opposite of our x value, well, that's 4 here, plus 1, that's 5. Yay! And I keep doing this. The opposite of 2, the opposite of -2 is +2. Add 1 more. The opposite of 0, well, that's 0.
That one was a hard one.
Now, the only other thing that I might advise, if you're looking to recognize slope and the other behaviors, don't jump through your table, go by ones. And I'll show you why. The slope here is actually -1, right? What is in front of the x? The slope is -1, which means every time we take a step forward on the x, we should be going down by 1. Notice we took 2 steps forward and we went down by 2. So a jump of 2 here is going to make a jump of 2 there. Jump of 1 is just going to make a jump down by 1, down by 1, down by 1, down by 1. So that slope behavior starts to help me be able to do that. Yes, yeah, so we're going to graph these 3 different graphs. I'm going to give you the next like 5 minutes to make it happen. I would color code it. This is where your colored pencils come in. Like, so if this, I put a blue box around, like that's going to be blue on my graph. Right, so you do B and C, make a table for them. If you already know how to graph it, that's up to you, but this, you probably are going to need a table for. I don't know that you'll know how to graph a parabola accurately yet, because parabolas are pretty tough.
Wait, but we can find the slope just from looking at the graph, right?
You can't.
But the equation's quicker, is that what you're saying?
This is just a strategy for any time that you approach a graph, especially ones that are difficult.
The first one wasn't terribly complicated.
Often these are actually the 5 that I use. -2, -1, 0, 1, 2. Just so they're all right next to each other. If you don't know how to graph it, you gotta make a table so we can find some points.
We're not graphing it?
We are gonna graph it.
Oh.
We're gonna graph all of these on the graph that we just made, but we first need to know what points we are graphing. So let's pull this together. For blue, right, what I have in blue up there, the first point we would graph is -4, 5. Right? So if I pull up my graph, -4, +5, I'm going to have a point here.
Okay, so it's
-2, +3,
over 3, down 3. Over 3, down 3.
0, +1, 1, 0, 2, -1, and this should create a straight line.
It does.
Yes, Hazel.
So quick, graph.
Yes, Hazel, as I already told you, that will be ignored until class is over.
How did you do that?
I just want you to graph.
Oh.
Did you do B and C also? I gotta move my one screen so you can see B and C again.
I can see C but not B.
Everybody look at your graph for a moment. I know you're doing B and C, but I want us to look at something real quick with each other. Please write somewhere on here that this was the graph of y equals, and up here would be perfect, negative 1x. That 1 isn't necessary, but we're going to put it anyways. Plus 1. This is your y-intercept of plus 1. Right? The slope being negative 1. If we put a point at negative 1, 2, right? If you're looking up at the screen, you can see what I'm showing you. And we go from this point down to this point. This is a run of 1 and a rise of negative 1. So when we would do delta y over delta x, that would be negative 1 over 1, which is how we get that slope.
I'm so what?
Calculating a diagonal here,
No, ask your question.
So isn't calculating a diagonal, wouldn't we do...
We're not calculating a diagonal.
Yeah, but this is diagonal. Does that not apply for that?
What do you mean by calculating? We're looking for what is the slope, like what angle. We're doing angles. We're not talking distances here.
Sorry, yeah,
No. Shh. Also not what we're talking about. I love you guys and what you know that is beyond what we're doing, but you have to stop thinking you know what your classmate's asking about. You're just going to confuse the people that aren't part of, like, you're bringing up stuff we don't need to confuse people with. Simon is wanting us to calculate distance, which we'll get to eventually this year, but that's not what we're doing right now. When we talk about the slope of an object, it is the amount of change from this point to get to that point. So also, I could do the same thing, but go down first and then go over, but it's still down 1 over 1, which is negative 1 over 1, which is a slope of negative 1. We're going to compare this to a value that should be positive. I am scared as I look at some people's papers. Your next line, and if you already graphed it, you might have some erasing to do. Your next line should have a y-intercept of positive 2. Because when we plug in x is 0, x is 0, right? 0 times anything, 0 plus 2, this is 2. Negative 2, what's half of negative 2? Negative 1 plus 2, positive 1. Well, if this is 1 and that's 2, I'm willing to bet this is right in between them at 1.5. And when I plug that in and do the math, that's right. When we plug in 1, half of 1 is a half. Plus 2, this is 2.5. And this is 3.
Good afternoon, Phoenix. Please pardon the interruption. At the class change, could I have the following students please stop by the office briefly? Sammy Bothager, Layla Siefley, Alana Shearer, Meredith Peters, and Marley Walker. That was Sammy Bothager, Layla Siefley, Alana Shearer, Meredith Peters, and Marley Walker. Please stop by the office briefly at the class change. Also, just a reminder that we have Cardinals tailgate tickets for sale in the Phoenix office until Wednesday at noon. The Cardinals will be doing a red out, so Cardinals fans, wear your red to the games. Thank you.
The other thing, like I keep just giving you guys multiple ways that we use this. Excuse me. The other thing the slope will tell us is if we've set up a table, every time we go up by 1x, every time we add an x, the y will go up or down by whatever the slope number is. So here, every time we add 1x, the y goes up by a half. Add 1x, up by a half. Add 1x, up by a half. Add 1x, up by a half. When we go to graph this, we see that. I think one of yours was goofed, right?
Yeah. I messed up the second one, so it wasn't
If we just plot the points, That's fine, but I'm going to show you another technique, so please put your eyes up on the board. This graph of 0.5x plus 2, slope, intercept. So the other way we could graph this is start at the intercept, right? They told us the intercept is 2. And then go up by how the slope tells us, right? That equation was y equals 0.5 x plus 2. This is our y-intercept. Boom. Our slope says every time we take a step on the x, we'll go up by 0.5. So if I step on the x, right, out to 1, then we got to go up by 0.5, which for me falls right in between there. That would be 2.5. I know it's kind of blurry. It'll come back.
How would you do that half a square thingy? Like the...
Because that's 2.5. That's where 2.5 is. So now when I take my x up to 2, what was at 2.5 is going to go up by another half.
Whoa.
When I step to 3, I'm at 3.5.
Pretty. We can just continue following.
I like graphs that work well.
And once you have a few points, 3 minimum, 5 is safe, we can connect. Now for the problem. The problem is the third one.
The third one is jerky to us.
The third one, I'm going to do this with you guys, is x squared minus 4. And I'm actually just going to write that on my paper over here.
2 times 2.
Wait. What was the red one? What did you put for the red one?
That was 0.5x plus 2. Red was 0.5x.
Was the y-intercept be negative 4?
Yes. Now the problem is the graph behavior beyond the y-intercept. So I'm actually going to make this green now, if we can. Sorry, I wrote it in blue, but I realized I shouldn't. If we make an XY table, couple negative, couple positive.
You're getting a lot of writing on a small space.
I'm going to go -2, -1, 0.
That's a huge U.
What's -2 squared?
4.
4 minus 4.
0.
What's -1 squared? 1 minus 4.
-3. -4. Wait.
Yeah.
-4.
1 minus 4, right? -1 squared. -1 times -1. 1 minus 4 is -3. 0 squared, 0 times 0, 0 minus 4. Well, -4. 1 squared, 1 minus 4. Oh, we're going to go back. -3. 2 squared, 4 minus 4. Oh, 0. So we have -2, 0. This is a point. We have -1, -3. This is a point. We have 0, -4. But then we have 1, -3.
It's uvular.
2, 0.
Terrible.
This.
Whoa. Math isn't nice to us.
What didn't you follow at all?
Hey, it turned into a smiley face.
So all of these are color coded, except this is the only table that I put here. Hey,
Pay attention in class.
hey, I'm out of time and I'm trying to take a classmate's question. Please don't be rude right now. For the parabola, which is the toughest, and I want to talk specifically about that because part of that's on your homework, what we did was we wrote down the equation, right? X squared minus 4. So we made a table, couple negative, 0, couple positive. We plug in the x value and then do the other math necessary. those points, x and y values, make the points. Those are what we graphed that went here, 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 and here. Those are these 5 points. And then we just connected them.
Alright.
Now we could do more points. We could do -3 and it would be way up here. And we could do +3 and it would be way up here. But we're out of time, so we're not going to. If you don't have a yellow sheet, please come grab one. We're out of time, so I just got to get you out of here. But please come grab one of these if you don't yet have one. I'll just set them down and get away.
I'll leave my ruler for next time.
They do need them, actually. If you want to leave your ruler, Math 7 needs rulers. So you can leave your ruler on your desk.